You can do any kinds of operations like this. Now, let's read in the files, one of the files that we have in our working directory. Let's call it mouse. Let's read the file mouse. Of course, we want to create an object that will store the data in the mouse file. And to read a file, to read a table, let's use the function read table. As simple as that. And what we have to tell it first, the first argument. So if you are inside, let me erase it. If you are inside the function read table, if you click on tab, or any function for that matter, if you click on tab inside the parentheses, RStudio will show you what are the arguments that it requires. So in this case, we start with file. Again, you have to define a character string, so you have to start it with quotation marks. And since we are already in the working directory, if we click tab, it's going to show you the two files that we have there. We just have to choose the mouse, and that should be all. In this case, and that should be all, actually, mouse. So mouse has, as you can see, 97 observations and 2 variables. This means that if I just type mouse, so this is what the table looks like. Let me extend this. So we have 2 columns. The first column has, oh, I forgot to tell it. So you have to specify header equals true, which means that the first line on that table is actually the header. So let me redo that. So mouse, let me scroll up a bit. And here we have the first column is for time, the second column is for temperature. Now, we have the table mouse. One thing that we can do if we want to visualize the data, let me make this big again because my plots are not going to show up otherwise. Let me make it a bit bigger. We can use the function plot. Again, if you click tab when you open the parentheses, it's going to show you what are the arguments. X, in this case, is mouse. We can just leave it as that, and it's going to plot the series. Below, it's the title of the column. So if you want to know what are the column names in your table, you use the function call names, type the name of the table, mouse, and it tells you what are the call names, the column names. In this case, it's time versus temperature. As you can see, time is set up on the x-axis and temperature on the y-axis. And the default way of plotting for R is using these dots, open circles, as points. So it's a point type of plot. Let me go back to the script. If you want to actually make it like a line, the only thing you have to do is to include an argument that says type equals open quotation marks L, which is for line. And now we change it to line. To lines. Okay, let's move on. Now, in our little exercise, one thing that we did was to try to specify, to try to fit functions. And we saw in class that we could fit actually a sine function, or a trigonometric function, could be a sine or a cosine function, to these data. And therefore, let's start again, and we're going to define a new x. Remember, you type x, which is the name of the object, and then you use this sign, which is like an arrow sign pointing towards the name of the function. And this should be equal. Now, instead of having just one number, we need a sequence of numbers. We need a sequence that goes from 0 to 10, which is what the range of values we have in the y-axis, in the x-axis. So 0 to 10. One way of doing that is that you can type 0 and then colon these two dots, these two vertical dots, 10. Let's run that. And if we go to the console and we say X and we click enter, now we have, instead of having a single value, we have a vector with or a sequence, if you want, if you rather call it like that, that goes from 0 to 10 with increments of 1. Okay, now we can make this sequence, instead of having increments of 1, we can make it to have increments of, let's say, 0.1, so we can have a more continuous feel of the function. To do that, let's go type x, and instead of using this type of notation, we're going to use a function, the function sec, which is for sequence. The function sequence, the arguments are from, we start at 0, the second argument 2, so how far are we going? In this case, we set 10. And then the last argument is by. By means, what are the increments? How far each observation should be from each other. Let's say that we want them every 0.1 increments. Let's take a look at that. Now, if we look at x, as you can see, x goes from 0 to 0.1 to 0.2, 0.3, etc. until it reaches 10. So it actually has, if we look at the length of x with the function length, it has 101, it's a sequence of 101 elements. All of them, the consecutive elements, all of them separated by 0.1. Now, we want to define y in this case, which is the f of x, as we set a sine function. And a sine function requires several arguments. So let's start with a times sine. So this is the function. It's a built-in function in R, sin for the sine. And then b times x. Of course, you might say, well, where do b and a come from? Actually, we have to define them before we run this. If I try to run this now, it's going to give me an error. As you can see, it tells me error, object A not found. So let's define A. And as we saw in class, A corresponds to the amplitude of the sine function. And the amplitude is given by the midpoint between the highest peak and the lowest peak. So this thing is ranging from 36 to 37 more or less. So it should go from 36.5 to 37 or from 36 to 36.5, which means that A can be somewhere around 0.5. Now we have A. Let's try to run it. Y. Of course, it gives us an error because we haven't defined B. Let's define B. So let's go back to the code. Let's say B is equal to, okay, now we have to define B, and we know that B is equal to 2 times P divided by the period. The period is simply the distance between the highest point and the next highest point, or the lowest point and the next lowest point. So the period tells us how long does it take to get from this point to this other point. And I'm saying how long it takes because our x's are in terms of time. And as you can see, this is more or less one time step. So we can define B as 2 times pi over 1, which is the period. Or we can simplify it. We know that 2 times pi over 1 is equal to 2 times pi. Now we can run B. So let's run B, and now let's run Y. And now Y, there's no errors because we have all of the elements that we need to define for Y have been defined. So let's take a look at Y. There you go. Now, if I try to plot, so Y on top of this it's not even going to show up. Well, let me just simply plot X, Y. Well, let's plot it as a line. This is what it looks like. Actually, the midpoint is at 0. And in our other plots, so if you click on these arrows, it's going to take you back to the previous plots. The midpoint is at 36.5. So actually, we need an additional argument, an additional coefficient. So we need to raise the entire function y by a certain amount. Let's define that as a point D, as a coefficient D. And the coefficient D needs to be 36.5 because remember the midpoint between this periodic um, system is about 36.5 degrees. So let's now add up D to our Y. And just for simplicity, I'm going to copy this plot here, just paste it here, so we don't have to go back and forth. And let me run it again, just so that you see. Let me run this whole part here. So the D and the Y, as you can see, what I did here was to select two lines. If I want to run two or more lines at the same time, I have to select them and then again press Command and Enter or Control and Enter depending on which platform you are. Now what we want to do is to draw. So let's change this plot as instead of type equals line, let's change it by points because we want to plot the line of Y on top of it. So that's how it looks like. And to plot the line on top, we can use these lines. Let's see what are the arguments we need. X, in this case, X is equal to X. In fact, the X argument of the function is X. The Y argument, so what is the other argument? It's Y, which is actually Y. And then let's change the color. Let's say that we want red. We can specify it either by number or with a character string. Let me do the character string with double quotation, red. So let's run this and plot this whole thing. And as you can see, it still needs some work, and this is the work that we did in class. But this is the idea. So these are some of the basic functions that you can use with R, and these are some of the basic things that you can do. And this is the general notion of what I'm expecting you to do with this week's exercise. We will have a bit more of R tutorials of this sort in the future. I hope you like it and I hope it works for you. It helps you. If you have any doubts, either ask me or ask your instructors. Thank you.